In this video, we've got another half-life model, but in this time we're looking at the half-life of a drug in the bloodstream. So the half-life of Xanax is 36 hours. That means the amount of the amount of Xanax in your system is 1/2 of your dose after 36 hours. So what we're going to look at is we're going to find how long it will take for the Xanax to decay to 90% of its original dosage. So that means 1/2 of the amount at e to the k times 36. The natural log of 1/2 is equal to 36k. That means that k is 1/36 of the natural log of 1/2, or it's the natural log of 1/2 divided by 36. And I'm going to find that in my calculator by taking the natural log of 1/2, and I'm going to divide it by 36, and I'm going to store that as my variable. So our decay rate is negative 0.0193. We'll keep three significant figures. Negative 0.0193. And notice how this is a much larger k than in our previous example. In our previous example, our half-life was 7,340 years, and we had a very small decay rate. In this example, our half-life is 36 hours, and we have a much larger decay rate. But since they are decaying, they are negative in both cases. That makes my model for A of t equal to A naught e to the negative 0.0193 t. And we're looking for 90%, so 0.9 A naught of the original dose is the original dose times e to the negative 0.0193 t. The A naughts cancel. We're left with 0.9 e to the negative with the t's. 0.9 is equal to our exponential equation. That means that the natural log of 0.9 is equal to the exponent of that equation. So t, the time, is the natural log of 0.9 divided by k, the decay factor. It's the natural log of 0.9 divided by a negative 0.0193. So I'm going to take the natural log of 0.9, and I'm going to divide it. I'm going to divide it by that number that we found, which again I stored as a variable, and I'll get 5.47. So t is equal to 5.47. I'm going to have to guess that that's going to be in days then. Oh, decay to 90% of its original dosage. Okay, I thought for 90% of it to decay. We always want to check and see what we're talking about. So hours. So t is equal to 5.47 hours, and we would say after 5.47 hours, 90% of the dose remains. That means if we had 100 milligrams after 5.47 hours, it would be 90 milligrams. Right, okay, and that's why that's much smaller than 36, because we're looking for 90% of it to remain. We always want to be checking our answers and making sure we've got our, we're describing the correct thing, and make sure of what we are describing. Okay, that's it for this video. Thanks.